In this video, we begin chapter 2, which is titled Applications of Differentiation. So in this chapter, we will learn how to use the derivative rules that we just learned to find maximas and minimas mostly, and also to find inflection points, and finally to graph some curves. In section 2.1, we will be using the first derivative to find the maximum and minimum values of certain functions, and then we will try to sketch the graphs of those functions. Before we begin this whole discussion, we need to know what a critical number is, and this is the definition of a critical number right here. A critical number or a critical value of a function is any number c where the function exists at that location, so f of c exists, and the derivative f prime of c, so the derivative at c, is either 0 or does not exist. So in other terms, if you want the critical value, what you have to do is find the derivative, then figure out what makes the derivative equation equal to 0 and what makes the derivative equation undefined. Those numbers that you get are called the critical values. Why is this important? This is important because later on we will show that critical values are the places where you will have a maximum or minimum. So by finding the critical values, you're halfway there to finding the maximum and the minimum. So let's begin with example number 1. And our goal here is to find the critical value or the critical numbers. So we will start by finding the derivative. Using the power rule, we can differentiate this expression a few times. So the first one, derivative of 2x cubed, is going to be 6x squared. Derivative of 3x squared is going to be 6x. And then derivative of 12x is going to be 12. Then finally, the derivative of 12 is going to be 0. So once I have the derivative, I'm going to try to factor it. So let's see, if I factor this derivative, what would I get? First of all, there's 6, 6, and 12, so I can factor the 6 out. That would leave me with x squared minus x minus 2. And now I'm looking for two numbers that multiply to negative 2, but when I add them, they add up to negative 1. And those numbers will most likely be 2 and 1. As long as I go with negative 2 and positive 1, the job should be good. So that tells me, therefore, that the derivative can now be written as f prime of x equals to the 6 on the outside, and then x minus 2, followed by x plus 1. So there's my derivative. It's ready to go. And now the question is, what makes it equal to 0 and what makes it undefined? So for the derivative to be equal to 0, this happens when either the x minus 2 is 0, or when the other parentheses, x plus 1, is equal to 0. Remember, the 6 on the outside doesn't really play a huge role right now because 6 will always be 6. It can never somehow become somehow 0. So there's no way it could be 0, so we can just look at the parentheses. So the first parentheses will be 0 when x is 2, and that's my first critical value or critical number. The second parentheses will be 0 when x is equal to negative 1. Now, what makes the f prime of x undefined? So in this case, the derivative cannot be undefined. Why is that? Why can it not be undefined? Well, that's because the derivative does not have a denominator. And since there's no denominator, that means there's no numbers that are forbidden. So that's it. We're finished.